Is the first one a little bit tricky? What kind of reaction is it? It's got carbon and hydrogen reacting with oxygen, and it's producing carbon dioxide and water. Only one reaction type does that. Give you another hint. This gas is methane. It's fart gas. Can you theoretically light a fart on fire? What kind of reaction has to do with burning fuel? Combustion. It's a combustion reaction. They're the trickiest ones. Okay, let's go over that one just because combustion reactions are the trickiest. Okay, so this is a combustion reaction. Okay, are there special rules for balancing a combustion reaction? Okay, first I balance in what order? Alphabetical for a combustion reaction. Okay, and then there's the rule of two that says if I have an even number of carbons, I start with a 2. Do I have an even number of carbons in this one? No. Okay, 1 is the loneliest number, and it is also the first odd number. Okay, so I don't have to start with a 2. Okay, I got 1 carbon here. Do I have 1 carbon here? Okay, so that's already good. I have 4 hydrogens here. How many here? 2. So what needs to go in front of this? All right, now I've got 4 hydrogens. Now I look at my oxygens. How many oxygen here? 2. How many here? 2, right? 2 times 1 is 2. So 2 plus 2 is 4. 2 times 2 is 4. Okay, that's a weird one, by the way. Plus and multiplying, it comes out to the same number. So that's what that one should look like. Okay, that's the trickiest kind. Okay, combustion are definitely the trickiest kind because they have all their own rules. Okay, let's try the next one together as well here, just so that we have it. For naming here, we've got this would be carbon tetrahydride. Okay, it's molecular, so we'd use the molecular naming rules. It's also commonly referred to as methane. Okay, plus oxygen. Okay, gives water. Water is, by the way, the only compound you can use the common name for. Okay, don't bother trying to write like dihydrogen monoxide or hydrogen hydroxide or hydrogen monoxide or any of that kind of stuff. Just don't bother. Okay, just write water. Water's good. Okay, and then plus carbon dioxide. Okay, all right. Looking at the next one. So this reaction starts with only one reactant. And then there are 2 products that are both elements. Okay, what kind of reaction is that? Simple decomposition. Okay, so we would write that that's a decomp reaction. Okay, so that's the first thing we do. We identify the type. All right, and then we would write it out in words. This is a molecular compound, so that would be trinitrogen disulfide. Okay, and that's, what's this stuff? What does N stand for? Nitrogen. Okay, does it matter that it's a 2? No, it's one of the special elements. Okay, it's nitrogen. On that note, what's the next thing? Sulfur. It's the most special of the special ones. Okay? And it comes as an 8, but it doesn't change its name. It's still just sulfur. Okay. All right, now we got to balance this one. So only combustion has its own rules. Everything else obeys the same balancing rules. Start with the biggest number. What's the biggest number? 8. 8's the biggest number. You always want to balance the biggest one first because it's likely going to make everything else fall into place. Okay, so I've got 8 sulfur over here and I have 2 sulfur over here. How do I balance that? You're right. Put a 4. Yeah. okay? So I put a 4 in front of this. Now 4 times 2 is 8, and 1 times 8 is 8. All right, but when I put that 4 there, it also applies to the nitrogen. What's 4 times 3? 12. What needs to go in front of this? Right, now it's balanced. Okay, start with the biggest one, balance it first, and then kind of fall down the stairs, okay, for the rest of the reaction. Right, and it'll work itself out. All right, I want you guys to try the last 3 here. See how we do on those now that we've done a few to review. There aren't any more combustion, spoiler alert, okay, on this. Okay, let's look at the next one here. So in the next one, I have an element reacting with an ionic compound, producing a different element in a different ionic compound. What kind of reaction have I got going on? Single replacement. Okay, so first thing we would write, single replacement, SR. And now we have to write the names for everything. What's this stuff called? Chlorine. It's just the element, right? This is one of our special elements, so we just call it what its name is on the periodic table. If you have an element that's by itself, even if it has a number beside it, you still call it its name from the periodic table. Right? And then it's reacting with sodium iodide. Okay. And then on this side here, what would this stuff be? Just iodine, yeah. And it's reacting with, or sorry, it's out there with sodium chloride. And now we got to balance it. So 2 is our biggest number. It's on 2 different elements, so it doesn't really matter which one I start with. I'll start with this chlorine just because it's first. There's 2 chlorines here. How many here? Just 1. So what needs to go in front of this? The 2. Okay, when I put that 2 there, it gives me 2 sodiums. So I got to go back over here and make sure I have 2 sodiums. And as soon as I do that, I get 2 iodines, which balances out my iodine. And now I'm finished. Right? All balancing works that way. You just jump back and forth from reactants to products until everything is balanced. How many people have done this one? Okay. Anyone want more time on that one? Let's have a look at it. So we've got an ionic compound reacting with an ionic compound, producing a different ionic compound and a different ionic compound. What kind of reaction is that? Double replacement. All right, in a double replacement reaction, I've got to name the compounds here. This is going to be calcium chloride. This stuff is sodium carbonate. That's going to produce calcium carbonate. And sodium chloride. Double replacement reactions always take forever to write. Oh, sorry, we forgot to write double replacement. What should I balance first? Biggest number. This is why I put this reaction on here. What's the biggest number?
Sodium carbonate.
Okay, sodium carbonate. Okay, we've got the biggest number in there, but is the biggest number 2 or 3? 2. Remember, carbonate is a polyatomic ion. How many carbonate ions are in that compound? Just 1. That's why I put it in there, so we see the difference in which numbers are important and what do they mean. Okay? While this number is important, it tells us it's carbonate, it's not how many carbonates there are. There's only 1 carbonate. Does everyone follow the difference? So we'll start with sodium because it's got a 2, okay? So does chlorine, but thankfully they end up together. 2, 2. If I put a 2 here, do I balance both the sodium and the chlorine with that 1 number? Did I also balance the whole reaction with that number? Yeah. Yeah. Oh, sorry. We'll put this back. Okay. So sometimes it works out like that. Sometimes it's that easy. One number fixes the whole thing. And sometimes, just sometimes, it's even easier than that. Why is the last one such an easy balance? Yeah, well, and there's no little numbers, right? Everything has a charge of 1, and there are no subscript numbers. That means everything is a 1. So it's already balanced. We can double check. 1 hydrogen, 1 hydrogen, 1 hydroxide, 1 hydroxide, 1 chlorine, 1 chlorine, 1 potassium. Yep, it's already balanced. If you don't see any little numbers, you're done. You don't have to balance anything because it's already balanced. That doesn't happen very often. Okay. What kind of reaction is it? Double replacement. Okay, everything's an ionic compound. And if we're writing it out, this stuff is hydrogen chloride. Plus potassium hydroxide. What's this stuff? Or? Is that a tricky way of writing water? Water can be written 2 ways in a reaction, as H2O or HOH. Either way, it's 2 H's and 1 O. It's still water. Okay? No matter how you write it, it's 2 H's and 1 O. This is just water. Okay? If you wrote hydrogen hydroxide, that's fine, but you can call it water if that's what it is. Why would we write water different ways? That's the reason I put this reaction on. In a combustion reaction, I write water as H2O because it's easier to balance that way. The hydrogens and the oxygens are separate. Okay? In a replacement reaction, where I get water from hydroxide, it's easier to balance if I write water as hydrogen hydroxide. Then I see where the hydroxides are, I see where the hydrogens are, and I can keep track of them better. So in a replacement reaction involving water, you're better off to write it as HOH. In a combustion reaction, you're better off to write it as H2O. It's just easier to track everything. Right? It isn't wrong to write it H2O in here. It's just harder to track where everything goes. Making sense? Okay. So you would get some questions like this, okay, on a quiz or a test where you are given the reaction and you have to identify the type, write it in words, and balance it. But you could also get it the other way. I give you the reaction in words. You write it in formula form, identify the type and balance. Which is harder? Give it to you in this form and make you write it out in words, or write it in words and make you give it to me in the formula form? Statistically speaking, harder if I give you the word reaction. People forget things like dropping and swapping, special elements. Like if I gave you this reaction in words, people would write N and S, and they'd forget all about the little numbers. And going from words to formula is much trickier because we have to remember more stuff. And we have to do more stuff. We have to remember this one's molecular, this one's ionic, I got to drop and swap. And if I get those wrong, if I get my drops and swaps wrong, am I going to balance the reaction correctly? Because I'm going to have the wrong numbers. It snowballs really quickly going from word to formula if I don't know how to write formulas very well. Okay? That's why I kept saying it's really important that we can do that well. So if you're still struggling with it, that's okay. But you got to come in and see me for some help on it. All right. Let's have you try just the first 3 here. There is a combustion reaction in there. Okay, so you got one of those tricky balances in there. For these ones, let's just say type and balance. Okay, don't have to write these ones out in words, just type and balance. All right, let's have a look at the first one. What kind of reaction is the first one? Synthesis, yeah. We got an element reacting with an element to form a compound. Okay, in this case, it's sodium and chlorine forming sodium chloride. All right, so we would have a synthesis reaction for that one. And being able to identify the reaction type, guys, is really important. There's going to come a time, not far from now, when you're going to have to predict the products of a reaction. To do that, you have to be able to identify the type from just the reactants. We only know 5 types of reactions, and they all start differently. Synthesis is the only type that starts with 2 elements as reactants. Decomposition is the only type that starts with 1 reactant only. Combustion is the only type that's carbon, hydrogen, and oxygen on the reactant side. Single replacement, element and ionic compound. Double replacement, 2 ionic compounds. It's easy to tell them apart, even just by their reactants. In this one here, right now our biggest number is the chlorine, 2. So what needs to go here? 2. That 2 now balances my chlorine, but it also applies to the sodium. Now there's 2 sodium in the products. How many are there here? Well, right now there's just 1, right? But I've got to put a 2 here. Now we talked about this before, but I just want to remind you, why can't I just do that? That means they're bonded together. Okay? Sodium doesn't do that. I would need 2 sodium atoms, not a molecule of sodium, because there's no such thing. Metals do not bond to themselves, except hydrogen. Okay. All right, what kind of reaction is the second one? Combustion. Carbon, hydrogen, oxygen. Combustion reaction. What are the special balancing rules again?
Alphabetical order.
Alphabetical order and the rule of 2. Hey, remember the Yoda voice. Okay, I did it for a reason. So you'd remember the rule of 2 says that if I have an even number of carbons, I start with a 2. All right. 2 times 8 is how many if I'm balancing in alphabetical order? Carbon first. 2 times 8? 16. All right, I got to do a little math on this one. Get some big numbers here. 2 times 18 is 36. All right. 18 times 2. This is the benefit of this, guys. Whenever you're doing one of these, it doesn't matter what this number is. That's the number that's going to be over there. Okay. Now that I've got those numbers in, now I can balance my oxygen. I've got 16 times 2 is 32 oxygens, plus 18 times 1 is 18. That's 50. Okay. What times 2 will give me 50? 25. This is likely the chemical reaction that got you to school today, unless you walked. Okay. If you drove here in something other than an electric car, okay. I mean, if you came here in an electric car, good for you. Okay. But if you came here in something powered by internal combustion, that is the reaction that got you here. That is octane. This stuff in gasoline. If you've ever filled up your car, there are 3 different grades of fuel at most gas stations. Regular, mid-grade, and premium. And they all have an octane rating on them. 87 octane is regular, 89 octane is mid-grade, and 91 octane is premium. They all contain different amounts of this stuff and thus burn hotter. Premium gas burns hotter than regular fuel, and as a result produces a bit more energy. Should you put premium fuel in a car that doesn't require it? Definitely not. Okay, used to be a thing you could do, but now they got all this computerized like emissions control stuff, and it'll really foul up the computer if you do that. So if your car says premium, put premium in it, because putting regular in a premium car will equally foul it up. Okay, and make sure you put the right grade of fuel in there, because it does make a difference. All right, for number 3, what kind of reaction are we looking at? Single replacement. Element reacts with ionic compound, produces ionic compound and element. What should I balance first? Biggest number is 3, but 2 different elements. 2 different elements have a 3, lithium and calcium. Which one should I do first, or does it not matter? There's a reason I put this reaction on there. Actually, the reason I put it on there is that it does matter which one you choose, and you should balance the one with the bigger charge first, because it can affect the reaction more. It will require calcium, because it has a 2+ charge, will require more nonmetals to balance it off, as opposed to lithium, which only has a charge of +1. So when this happens, okay, in the end, it won't kill you if you do it wrong. You'll just end up having to start over again with calcium if you do it. You might be able to, sometimes it works out. All right, so I'm gonna start with calcium here. I've got 3 calcium on this side. If I put a 3 over here, the calcium now works. All right, the nitrogen here, there's how many? 2. So what do I need to put in front of this? Okay, a 2. This is why I didn't balance lithium first. If I had balanced lithium first, I'd have gone over here, put a 3 here, and then I'd have gone, oh wait, my nitrogen's not balanced. Then I would have had to come back and balance the nitrogen. Okay, it just wouldn't, I would have had to start over. It happens sometimes. Is it the end of the world? Absolutely not. You just erase the numbers and you start with a different thing, and then it'll work out. Okay. All right, and sorry, we need 6 in front of the lithium over there. Okay, so here's the thing. This just takes a lot of practice. Okay, there's no secret formula to being good at reactions other than doing lots of them. It's why we spend so much time on reactions, because this is just the first bit. Okay, giving you these reactions and saying identify the type and balance, that's about as easy as it gets. Okay, we've still got to get into going from words to formula, okay, and also predicting the reactions. So do I have some that are the other way? Let's have you just try number 6 for right now. Okay, so this is what I was talking to you about. Now I give you the word reaction. Now you gotta write it in formula form, identify the type, and balance. It'll be a little bit trickier. So when you're going from word to formula form, you've got to make sure you get the formulas right. Okay, otherwise the balancing part is going to go haywire on you. So copper 2 nitrate. So it's the copper with the 2+ charge. It is with nitrate that has a 1- charge. So we drop and swap. This is going to need brackets with a 2 outside. And it is reacting with magnesium. That's just Mg. It's not special. Okay, I'm not trying to hurt its feelings, it's just a metal, they don't do that. Okay, and it's gonna form magnesium nitrate. Okay, magnesium's a 2+, nitrate is a 1-, drop and swap, that's gonna need 2, okay, plus copper. All right, so I've got my reaction written out. What kind of reaction is it? I got an element reacting with an ionic compound. Okay. Single replacement reaction. Okay, guys, we got to be able to do that. That's got to be pretty much automatic. Okay, when you come back from the break, I need you to have studied those 5 reaction types. So if I show you a reaction, you can tell me right away. Okay, it's this type. All right, so it's a single replacement reaction. Now I have to balance it. Done. It's already balanced, isn't it? How many nitrates here? That's a 2. It's my terrible penmanship, that's a 2. How many nitrates here? 2. How many nitrates over there? 2. 1 magnesium, 1 magnesium, 1 copper, 1 copper. I'm already balanced. Those can be tricky, because you doubt it, right? You're like, oh, there's no way it could ever be that nice. It happens sometimes. Okay, rather than do the combustion one, I would like you guys to try number 8, because number 8 is going to illustrate a couple of really important things about when you go from name to formula. So first thing is, we've got lithium nitride to start off with. Ionic compound, so I've got to do the drop and swap. Lithium is a +1, nitride is a -3, so when I drop and swap I get Li3N. And it breaks down into nitrogen and lithium. What do I need to remember here? Nitrogen special. It comes as a pair. Okay, that's what I'm trying to illustrate with this example here. It is so important to always be on the lookout for special elements. They're trickier when it's in word form because there's no indication that I need to put a 2 there on that particular reaction. Now when I balance, if I've forgotten that, I'm going to balance it wrong. So it really snowballs. If this is a 3-mark reaction and you forget that that's a 2, you're going to get 1 out of 3 if you're lucky, if you didn't make any other mistakes. So when I'm balancing here, while lithium is the biggest number, I can't balance it first, can I? Because if I do, I'm going to go over here and put a 3 in front of this and then go, oh crap. Nitrogen's a 2 and there's only 1 over here. Now I got to erase the 3. And I mean, that's really problematic and probably tire me out and I won't want to do anything else. Okay. So I'm going to balance my nitrogen first and then I'm going to balance my lithium. Okay. Is it the end of the world if I forget that? It's not. It happens. We say the rule is start with the biggest number and go from there. We have that rule because it works a lot. Okay? Probably more than 90% of the time, starting with the biggest number will get it all done. There are the odd exceptions. The exceptions are usually decomp reactions. Usually. All right. Number 9 also has something in it that I want to illustrate, so it's a good example. Let's try number 9 real quick here. Okay. Actually, maybe we'll just go through it because we only have 4 minutes left. So I've got hydrogen sulfide, ionic compound. Okay, make sure you write this one down, guys. And it's with sulfur, -2, so H2S. And it's reacting with calcium hydroxide, CaOH. That'll be bracketed to 2. Okay? And it's going to produce calcium sulfide. That's a -2, that's a +2, so that compound is good. Plus water. How should I write water in this reaction? H2O or HOH? HOH. In this reaction, it's better to write it as HOH because it's easier to keep track of the parts that way. If you see a hydroxide on one side and water on the other, write water as HOH and it'll be way easier to balance it. On this side, I got the biggest number is 2, and it's with both hydrogen and hydroxide. Boom. Reaction's balanced. And that's all I have to do. All right, we're going to pick up with that after the break. A couple of things while you're packing up, so pay attention while you're packing up. Okay. When we come back after the break, it's going to go kind of quick. You got your lab report that's going to come due. We're going to be working on reactions, which is pretty intense. We're going to have another lab, probably on the day your first lab is due. We'll probably be doing the reactions lab, or maybe the day after that. Okay, it's going to go fast. You got to be rested and ready when you come back to hit the ground running. Okay, because that's exactly what is going to happen when we come back. Over the break, should you work on your lab report? So you can come and see me, right? And have me look it over. Don't email me over the break and go, hey, Claire, can you look over my lab? You will hear crickets. Okay? But I will happily look it over in person. Okay? That's how we do things. Come in and see me in person, and I will happily look it over for you when you come back. Okay? There's something else, and I don't know what it was. Oh, yeah. Be good over the break. That was good. Okay. Want to see you all after. Okay. All right. That's it for today, guys.